So here comes a power outage. It could be a hurricane, it could be anything else, and you need power. You may be thinking of a standby generator or a backup generator, and this is what I will be talking to you about. My name is Jorge Vargas, company name is Genesis Fortune, and I would appreciate if you can help us by giving us a like and subscribing to our channel. So, let me just draw something simple for you to understand. What does it take for a standby generator to work? I'm going to draw what is going to be, let's say, your house. As you can see, drawing is not my forte. And you have to provide power to this house. This house has what we have on the outside, maybe has like a meter and an electrical combo panel. Combo meaning like it may have the meter and it also have some breakers on the outside. This house is normally fed by, let me put it in a different color, by some distribution power from a local utility. So that power comes in form of different poles set on the street, and at the end it has like a small transformer, and from the transformer you have power coming into the house. That is, the power lines obviously run through the poles and get into the transformer. So I make it very simple. This is just one phase power, boom boom, and it gets into the house. So when there is a fault in the system and the power is disturbed, and I'm gonna make this also in maybe red. Boom. There is no more power. It used to be power coming this way, and now there is no more power getting into the house. So what happens? You need to generate power by yourself if you want to have a continuation of power. So if that power gets interrupted, that's when you have to get yourself a standby generator or a backup generator. I will explain a little bit the difference between the two. So for now, let's assume that you decided to have that standby generator. And for that, I'm going to draw it with a different color. I'm going to put here the standby generator set on a concrete slab. And a generator is nothing more than an engine connected to a dynamo that move the combustion engine, move the electrical part that actually generates power. So how you make it safe the power coming from the generator into your house and connected at the same time through the utility. So this is how it works. Between the house and the generator, and between the house and the power utility, you have what is called an automatic transfer switch. Here's a box, usually called ATS. I will put here in the description, this is called automatic transfer switch. So it's just a switch that gets power from either the utility or from your generator. So imagine that inside this automatic transfer switch, you have something that moves either from this position or to this position. On one side of the switch, you have the power coming from the generator, and on the other one, you have the power coming from the utility. Then from the automatic transfer switch, that's when you have the power going into, I'm gonna put it in a color that is also visible. Let me choose a different color here. Actually, let me make it blue, same as the house. Oops, sorry about that. Okay, so it's now blue, going like this. So as you can see, the automatic transfer switch can take either power from the utility or from the generator. When does it take it from one or the other? As the word says automatic, you can set it up that it's usually in a normal mode taking power from the utility, the black line. And if the black line gets interrupted, meaning if the utility, I'm going to call this here again, this is the utility word, utility. If the utility power gets interrupted, the ATS or the automatic transfer switch will go to the position below and then take power from the standby generator. Once that happens, the standby generator has its logic to start running and provide power. So the house can take power from either of the two, but obviously not the two at the same time. Yes, I guess follow-up question that you may have is, okay, how do I know what size standby generator I need to buy in order to provide power to my house? And that would be a question kind of like easy to answer, but not always financially available for most of our clients. To make it simple, the house will be consuming X number of watts. So if you have a total number of watts, let's say this is the number of kilowatts that you have in the house, you will get a generator that the specs can provide that number of kilowatts. Now, if you don't have the money to buy a generator that big, because maybe your house is too big and you only want to have a backup or a standby generator, to supply power to only a portion of the house, then what you need to do is to connect a separate, instead of this electrical panel that you have for the whole house, you will have a separate panel that is called an emergency panel that will be the one dedicated for the standby generator. Another way to solve this problem, if your generator still is not capable of feeding the whole house, you can buy the logic inside the generator that it tells, listen, if I turn on too many lights, too many appliances at the same time, and you see that you cannot keep up with all the load, it is okay for you to shut down. Because I don't want to get into frequency, but if the frequency starts going down, and remember we need to, and I'm taking this video in Miami-Dade County, Florida, and in the United States, you know that we have to keep the frequency running at 60 hertz. If you go below 60 hertz, the generator will find out and automatically will shut down. So there are different ways for you not having to buy a generator big enough for the entire house, and this is something that obviously you need to consider. But there are ways, as I said, to either run the whole house or not, depending on the logic that you put in your generator. And obviously all this that I had explained right now, I highly recommend you that obviously you will have to get in contact with a professional and licensed electrical contractor to do the installation, to have drawings, like a professional electrical drawings that can say how it's going to be done, what load you're going to have, if the generator is big enough or not, if you need some logic to shut down the generator in case you're putting too much load on it. So those things is something that you shouldn't be doing by yourself if you don't know how to do it, if you don't have the professional license and knowledge. The other thing that is a little bit scary, if it's done not the right way, is when we are talking as a backup generator. When most people during the storm, they decide to buy backup generators, this is what they do. They go ahead and they have the same typical scenario where you have the house. I'm gonna draw the house again. And they decide into the electrical meter combo box on the outside. They come here and they said, okay, I want to have a backup generator. Usually it looks something like this, right? I'm gonna bring it from the garage and I will hook this generator directly into the internal lugs of my electrical panel to fill the entire house. And you may think that that works and that is fine because your house is now being fed. Obviously, these backup generators are usually smaller in size than typical standby. I'm pretty sure there may be big, humongous backup generator, but I'm talking about average size. Usually they are smaller than standbys. So this is the generator here. What happens is that some people who don't know what they're doing and they think they do, they don't know this, that when you are powering your house, you forget this, that you have power from the utility. Obviously that power has been interrupted, right? And let's say it was interrupted here. So there is no more power coming this way for some reason, whatever reason. Let's say that the line broke right here. So there is some cables down, and this one is also down like this. Now your house had always been connected from this transformer into here. So right now, this is the problem. The power from the utility got interrupted. Now you're powering your house through a generator. And it's true. But the power is not only going into your house, the power is also going through the utility cable back into the lines. And that is very dangerous when people are working, trying to do restoration of power during a storm, because the utility workers will have to take into account that there may be power going through the lines. So you're feeding your house and you're feeding a portion of the grid, the utility electrical grid. So please be careful when you're doing these things, and always try to get the right licensed contractors, so they know what they're doing and they can do it safe, not only for you but for the rest of humanity. I hope that you enjoyed this video, and if you have any questions, feel free to call us and we can give you a little bit more of suggestions on what you should do. But actually, before I finish this video, I think that it would be a good idea for you to see this in a real project that actually we're working on. I always try to come out with and show you what it looks like when we have to design something like that. The next, not the next, but I'm gonna move my screen to the computer, and you will see what looks professional drawings, actually done by us, These are our drones. But you can see how two fire pumps, pumps that they use in emergency for fire, are being fed in a building from either the utility or from a standby generator. And this is the real construction drawings, electrical drawings that I was going to talk to you about. As you can see, these two switches are automatic transfer switches. These two switches, and we can see one of them because both of them actually they mean the same. You can see that, let's pick up this one right here. They can either switch from this position or to this position. What is that they're feeding? If you see here, they go into an existing fire pump. This fire pump needs power, but it can take it from either two positions. If it's going to go from this position at the bottom, and we follow the line all the way to the left, you can see it comes from, in this case, it's an existing disconnect. This disconnect is nothing more than a disconnect from the electric utility. This disconnect is connected to a gutter. I don't want to get into the details, but this means the utility. Now, the other position for the same switch, the automatic transfer switch, is to get power, if we follow this line, from a generator. This is a standby generator that provides power in case of an emergency. So the automatic transfer switch takes power from one or the other. So it looks a little bit more complicated because we have to put more details, but the basics are the same as the drawings that you saw a few minutes ago. I hope that these drawings and these sketches have been helpful when it comes for you to decide on what you need to buy, on how you're going to implement that standby or backup generator. And if you have any more questions, I ask you to feel free to contact us at the number below or via email. And the only thing that I ask you at the end, as I always do, is please, if you think this video has been at least a little bit helpful for you, to give us a like and to subscribe to our channel. We try to provide as many videos as I can on a weekly basis on topics that are relevant to the society and to increase the knowledge for you to make smarter decisions. Enjoy.
I hope you enjoyed this video. Please subscribe and give us a like. We'd love to see you back again.